Some electrical installations look correct. Some electrical installations look correct, but they fail inspection because they violate basic code rules. Tonight we're breaking down common electrical mistakes electricians see on jobs and the code rules behind them. So a quick summary. Before we go deeper, here's the quick breakdown. Most electrical inspection failures happen because of grounding mistakes, neutral bonding errors, and incorrect breaker sizing. They are simple rules, but when done wrong, they create serious safety issues. So Rule 10-102, grounding required. So under Rule 10-102, grounding electrodes, it says see Appendix B. Grounding electrodes shall consist of A, manufactured grounding electrode, B, field assembled grounding electrode, or C, in situ grounding electrode forming part of existing infrastructure. Manufactured grounding electrode shall in the case of a rod grounding electrode, consist of two rod electrodes. Space not less than 3 meters apart. Interconnected with a grounding conductor, size as prescribed for grounding conductors, and driven to the full length of the rod. In the case of a chemical charge rod electrode, be installed to the full length of the rod, or in the case of a plate electrode, be in direct contact with exterior soil at not less than 600 millimeters below grid level. Or in the case of a phase plate electrode, be in direct contact with exterior soil at not less than 600 millimeters below grid level. Or in case within the bottom 50 millimeters of a concrete foundation footing in direct contact with the earth at not less than 600 millimeters below finished grid. A field assembly grounding electrode shall consist of A bare copper conductor not less than 6 meters in length, size in accordance with Table 43, and encased within the bottom 50 millimeters of a concrete foundation footing in direct contact with the earth at not less than 600 millimeters below finished grade. Or a bare copper conductor not less than 6 meters in length, size in accordance with Table 43, and directly buried in earth at least 600 millimeters below finished grade. Three, a field assembly grounding electrode shall consist of a bare copper conductor not less than 6 meters in length, size in accordance with the table 43. For the purpose of Rule 2-024, an in situ grounding electrode shall not be considered electrical equipment and shall provide at 600 millimeters or more below finished grade a surface area exposed to earth equivalent to that of a similar manufactured grounding electrode. For the purposes of Rule 2, sorry, I read that. Again, sorry guys. Welcome to the channel. Thank you guys all for tuning in tonight. Again, as you guys come in, don't forget to like up the live stream. Where a local condition such as rock or permafrost prevents a grounding electrode from being installed at the required buried depth, a lesser acceptable depth shall be permitted. So again, this is undergrounding, and the rule that I'm reading out right now is 10-102, grounding electrodes. It also says to see Appendix B, but I'm not going to go to Appendix B. And it also tells you to use Table 43. And it also tells you to verify Rule 2-024. So again, this is Rule 10-102, grounding requires. Again, electrical systems must be grounded. Grounding stabilizes voltage, protects against surges. Grounding stabilizes the electrical system and protects against dangerous voltage conditions. Service neutral connected to grounding electrodes. So right now I'm going to head over to bonding explained, which is Rule 10-400. For all of those who are tuning in to tonight's live stream, thank you guys for tuning in. Don't forget to leave a like on the live stream. So 10-400 is where I'm going to. Sorry, 10-204. So 10-204 is grounding connections for DC system. And it says DC systems that are to be solidly grounded shall have the grounding connection made at a single point as close as practical to the supply service. So that basically means that your service that you're going to install with your meter, and whether it be your service panel, main panel for the house, or a disconnect, that's where your grounding point is going to land as close as possible to the supply side. So again, Rule 10-204, bonding at service equipment. And bonding at service equipment simply says DC systems that are to be solidly grounded shall have the grounding connection made at a single point as close as practical to the supply sources. So neutral bonded at service panel, and that's basically what you're going to do. Neutral bonded at service panel. Um, Only one bonding path. Neutral bonding happens once at the service equipment. So what it means is the service equipment is basically your main service that's coming in to the house. That's where it's going to get bonded, and it's only one time you're going to do it. Basically, you cannot bond downstream. So main panel versus sub panel. So your main panel is basically your service panel, where your feeder wires is going to, your incoming power is coming in from the outside. That's where your main panel is going to be picked up, whether it be a home or it be commercial, industrial, whether it be a three-phase system or a single-phase system. Your incoming power is going to always land at the source where it's supposed to go, and that from there on you're going to pick up your other panels, which is considered a sub panel. So a sub panel, you do not bond a sub panel. Once you install your sub panel, your bonding straps also has to be removed from the sub panel. And again, for all those who are tuning into tonight's live stream, don't forget to like up the live stream. You can also join the channel. So a sub panel and the main panel is two different. Reason being is the sub panel you cannot bond after. You have to remove all of your bonding straps, whatever it may be, to avoid the dangers of livening up a second panel that shouldn't be livening up. So again, welcome back to the channel. I'd like to thank you guys all for tuning in to the live stream. So common failures that happens on job sites. Neutral bonded in a sub panel is something that you see a lot. It's also something that is going to fail inspection. Bonding at the sub panel. Again, you cannot bond again downstream. You can only bond once. So once the inspector comes to the job and he decides to check that over, and you didn't remove your bonding straps, he's also going to have you correct it, fail it. So neutral bonded in the sub panel, you cannot bond a sub panel. Again, it creates a parallel current path, and it also causes inspection failure. So neutral is bounded at the service, but isolated in the sub panel. So right now we're going to go into bonding continuity. For all those who are tuned in to tonight's live stream, don't forget to like the live. Please and thank you. Helps with the channel. And we're going on to bonding explain. This is rule 10 10-606. So again, Rule 10-606. You see it here on the screen for all those who are tuned in to the live stream. 10-606 simply says bonding continuity. Bonding path must be continuous. Fault current must return to the source. Bonding ensures fault current returning to the source so your breaker can trip. So on the screen, I have equipment bonding. You have conductors and parallel runs also. But I'm going to go to, again, bonding continuity. You have for service equipment. And it also says see Appendix B, but I'm not going to go to Appendix B. Again, Appendix B is very important when you're out in the field. You simply head over to the Appendix B to check what else information you can gather. So the bonding continuity for service equipment shall be assured by bonding means prescribed in Rule 10-610. So this basically takes you to Rule 10-610, where you're going to basically verify with that rule to make sure that it corresponds with this rule. So standard lock nut serving as the bonding means for metal raceways, metal sheet or cable armored connecting to service equipment shall be supplemented by bonding bushings with a bonding conductor connected to a bonding bus within the enclosure. So this rule here, which is 10-6042, this rule, if you check my past videos, you're going to see a disconnect installation 400 amps. You will see all the bonding materials that are used for the job, and that's where that rule came from, right here, as you can see. So again, the rules that we use on a daily basis, it all comes from right within this book. So this book basically is like a law book for us to protect ourselves from anything. So once followed correctly, shouldn't be any issues. Standard lock nut serving as the bonding means for metal raceways, metal sheet, or cable armor connecting to service equipment shall be supplemented by bonding bushings with a bonding conductor connections to a bonding bus within the enclosure. At both ends, where the metal raceways, metal sheet, or cable armor serve as the bonding means between service equipment, or at one end where that's B, and it says one, a bonding conductor is run with circuit conductors, or the termination to the service equipment is only at one end. Notwithstanding sub-rule 2, a bonding bushing shall not be required for cable assembly, incorporating an internal bonding conductor in continuous contact with the cable armor, provided that the internal bonding conductor extends from the cable and connects to the service equipment. So Rule 10-606, bonding continuity at other than the service equipment, says to go to see Appendix B. Again, I'm not going to go to Appendix B. I'm just going to stick with this rule that I have in front of me. And for all those who wants to follow it up, you can simply head over to Appendix B if you wanted to. And it's recommended, that you head over to Appendix B. Bonding continuity. So 10-6061A 1 says bonding continuity of metal raceways, metal sheeted cable, or armored cable shall be assured by one of the methods specified in Rule 10-6041 or by using standard box connections made up tight. B, 2 lock nuts, one inside and one outside of boxes and cabinets. So 2 lock nuts, one inside and one outside of boxes and cabinets. Or 1 lock nut and a metal conduit bushing, provided that the bushing can be installed so that it is mechanically secure and makes positive contact with the inside surface of the box or cabinets. And it also says 2, reducing washers shall not be used to maintain the bonding continuity of the wiring system. And if I want to go deeper, you have Rule 10-608, loosely jointed metal raceways, where a metal raceway serves as the bonding conductor and expansion joints and telescoping section are installed. The electrical continuity of the raceway shall be assured with a bonding conductor. So, where a metal raceway serves as the bonding conductor and expansion joints and telescoping sections are installed, the electrical continuity of the raceway shall be assured with a bonding conductor. So Rule 10-610, bonding means. So again, for all those who are tuned in to tonight's live stream, don't forget to give the live stream a like. And again, thank you guys all for tuning in to tonight's masterclass series. You can also join the channel, and you can also, or you can become a member of the channel. So bonding means fixed equipment. See Appendix B, it tells you the bonding means for the fixed equipment shall consist of one of the following: A, an effective metallic interconnection between the fixed equipment consisting of metal raceway, metal sheet, or cable armor, etc. Armored as specified in subrules 2 and 3. The sheet of mineral insulated cable when not of copper or aluminum as specified in subrule 4. Or where the raceway or cables are run underground, run in locations coming within the scope of Section 22 or otherwise subject to corrosion. A bonding conductor that is run with circuit conductors as a part of a cable, or a bonding conductor that is run with circuit conductors installed in raceways. The armor of, so this is 10-610 2. The armor of of armor cables incorporating a bonding conductor shall not be deemed to fulfill the requirements of a bonding conductor, except where both the armor and the bonding conductors are in continuous electrical contact. So basically, what a electrical contact, you have to maintain your bonding joints, electrical contact continuously. So again, for all those who are tuned in to tonight's live stream, thank you guys all for stopping by to the live stream tonight. And we're going to head over to section okay. So breaker sizing is what we're going to head over to right now. And that is basically rule 14104. And again, this is how you maneuver in your code book. Pretty simple. So these are all the rules that we have to know. As you can see, it's full of pages. So again, for all those who are tuning in to tonight's live stream, I'm trying to get to the rule that states breaker sizing, rating of overcurrent devices, and we're just going to go through that rule. Okay, so no rush. 14104 is what we're going to go over, and we probably might check out um, another code rule. Gloom platoon. Good night, Gloom platoon. Big up yourself, and again, thank you for stopping in to the live stream. So, Rule 14-104, which basically says, first I'm going to read out my note that I have here, and it basically says, overcurrent devices, breakers or fuses, must not exceed the ampacity of the conductors that they protect. So overcurrent devices, breakers or fuses, must not exceed the ampacity of the conductors that they protect. So basically what that means is your breaker, okay, or your fuse must not exceed the ampacity of your wires that you have. So breakers are designed to protect the conductors from overheating. If the breaker rating is too high, the wire can overheat before the breaker trips. Example, 14 gauge copper conductor goes on a 15 amp breaker. 12 gauge copper conductor goes on a 20 amp breaker. If someone install a 14 gauge wire on a 20 amp breaker, that becomes a code violation. So 14-104, and it says rating of overcurrent devices is also sending you to Appendix B. And what Appendix B is basically saying, sorry, I'm not going to go to Appendix B, but I am going to go to 14-1041. It says the rating or setting of overcurrent devices shall not exceed the ampacity of the conductors that they protect, except where a fuse or a circuit breaker having a rating or setting of the same value as the ampacity of the conductor is not available, and the maximum calculated or known load is in accordance with the rules of Section B. The ratings or settings given in Table 13 shall be permitted to be used within the maximum value of 800 amps. So I'm going to read over this again. Rule 14-104 for those who are tuned into the live stream. Don't forget to like up the live. The rating or setting of overcurrent devices shall not exceed the ampacity of the conductor that they protect. So what that basically is saying is the same thing I just said. If I have a 14 gauge wire, number 14 wire, I have to place it on a 15 amp breaker. If I have a number 12 wire, I have to put it on a 20 amp breaker. So this is where the rule comes from. So for all the apprentices who are tuned into the live stream, the journeymans, this is where this rule comes from. This is why a lot of times you will hear your journeyman say, place it on a 20 amp breaker, place it on a 15 amp breaker, place it on a 30 amp breaker. It goes with the wire size, and that's how we calculate basically the breaker size. So A also goes on to say, where a fuse or circuit breaker having a rating or setting of the same value as the ampacity of the conductor is not available, and the maximum calculated or known load is in accordance with the rules of Section 8. So this is basically sending you back to Section 8. Also tells you the rating or setting given in Table 13 shall be permitted to be used within the maximum value of 800 amp. In the case of equipment wire flexible cords in size, number 16, number 18, and number 20 gauge copper and tensor cord, which are considered protected by 15 amp overcurrent devices, or as provided for by other rules of this code. And 2 goes on to say, except as provided for by Subrule 1C, the rating of overcurrent protection shall not exceed a 15 amp for number 14 copper conductor. B, 20 amp for number 12 copper conductor. C, 30 amp for number 10 copper conductor. D, 15 amp for number 12 aluminum conductor. So notice it changed right there. So I'm going to read it over again for all those who are tuned in to tonight's live stream. So this, except as provided by Subrule 1C, the rating of overcurrent protection shall not exceed A, 15 amp for number 14 gauge copper conductor. B, 20 amp for number 12 copper conductor. C, 30 amp for number 10 copper conductor. D, 15 amp for number 12 aluminum conductor. And E, 25 amp for number 10 aluminum conductor. So you have the breaker rating with the wire for your copper conductor and also your aluminum conductor. So again, that was rating of overcurrent devices. So I'm going to head over to Rule 8-104. So I'm going to head back over to, and it's going to take us to the continuous load. So again, for all those who are tuning in to the live stream, don't forget to leave a like on the live stream. And also, you can stick around for the Q&A where you can drop your comments. So we're going to go to Rule 8104. Okay, so 8104. Let's see if I have this here right. Breaker sizing. Okay, so let's head back over to here. Okay, so section 8, circuits loading and demand factor. This is where you do all of your calculations and so on. So Rule 8-104 is what I'm looking for, and it is at the bottom. It also tells you maximum circuit loading. 8-104. It also tells you you can see Appendix B also, but I'm not going to go to Appendix B. It also says, 1, the ampere rating of a consumer service feeder or branch circuit shall be the ampere rating of the overcurrent device protecting the circuit or the ampacity of the conductor, whichever is less. So the ampere rating of a consumer service feeder or branch circuit shall be the ampere rating of the overcurrent device protecting the circuit or the ampacity of the conductor, whichever is less. The calculated load in a circuit shall not exceed the ampere rating of the circuit. So I'm going to tap the next page to see if this rule does come continue, and it does. So I'm just going to do a quick breakdown of this rule, and then I'm going to continue to read the entire rule there. So Rule 8-104, maximum circuit loading. Continuous loads must be calculated at 125% of the load, which results in the 80% breaker rule. So basically, 14-104 is going to lead you back to 8-104. They both correspond together. So continuous load must be calculated at 125% of the load, which results in the 80% breaker rule. A 20-amp breaker can only carry about 16 amps continuous. So a 20-amp breaker can only carry about 16 amps continuously. Breakers protect the conductor, not the equipment. If the breaker is oversized, the wire can overheat before the breaker trips, which is a serious safety issue. So I'm going to read out this rule here. And it goes on to say the calculated load in a consumer service feeder or branch circuit shall be considered a continuous load unless it can be shown that in normal operation it will not possess for a total of more than 1 hour in any 2-hour period if the load does not exceed 225 amps, or b a total of more than 3 hours in any 6-hour period if the load exceeds 225 amps. 4. A load of a cyclic or intermittent nature shall be classified as continuous unless it meets the requirements of Subrule 3. Where a fuse switch or circuit breaker is marked for continuous operation at 100% of the ampere rating of its overcurrent device, the continuous load as determined from the calculated load shall not exceed the continuous operation marking on the fuse switch or switch breaker. And so this is 5A for all those who are tuned in to the live stream. It is at the top of the page here. 5A, except as required by item B, shall not exceed 100% of the ampacity of conductors selected in accordance with the section 4, or shall not exceed 85% of the ampacity of single conductors selected in accordance with section 4. So also 6 goes on to say, where a fuse switch or circuit breaker is marked for continuous operation at 80% of the ampere rating of its overcurrent devices, the continuous load as determined from the calculated load shall not exceed the continuous operation marking on the fuse switch or circuit breaker, and except as required by item B, shall not exceed 80% of the ampacity of conductors selectors in accordance with section 4. So section 4, you basically have to head over to section 4 and see what it's telling you, section 4. Or shall not exceed 70% of the ampacity of single conductors selected in accordance with section 4. The continuous load as determined from the calculated load connected to a cable shall not exceed the value specified in Subrule 5 or 6. So you have appendix, you have 8-106 also, but I'm not going to read that. So basically, I'm going to be doing a quick recap here for all those who are tuned in to tonight's live stream. Again, thank you guys all for tuning in to the live stream tonight. Again, as you guys enter, don't forget to like up the live stream. So basically, a recap of tonight's live stream would have been grounding rules that I would have went over. Again, grounding rules 10-102. So that is what I started off with on the live stream tonight for all those who are tuning in and who's catching this on the replay. So grounding rules is what I started off here with, and basically what it says is rules 10-102. Electrical systems must be grounded. Grounding stabilizes voltage, protects against surges. Grounding stabilizes the electrical system and protect against dangerous voltage conditions. Example, service neutral connected to grounding electrodes. So that is one of the rules that I went over on the live stream tonight. The other rule was service bounding rules 10-204, and bounding at service equipment is the title for it. And the key points here on this rule is neutral bonding at service panel, only one bonding path, guys. Neutral bonding happens once at the service equipment. The difference between your main panel is your main panel is going to land beside where your main service entrance comes. That means whether it be your disconnect in Ontario or Canada, that's where we land our main service. In the disconnect outdoor of the homes, all disconnects are mounted outside. There are some disconnects that are mounted inside depending on if you're doing the meter base. All meter base are mounted on the outdoor. Depends if it's an older home. I have seen some older homes that have the meter located inside the home. But again, all meter bases for new homes are mounted on the outside of the home. And what happens now is you have a main service panel, and your main panel is where you're going to have your service coming in to pick up your main service panel. If you relocate that panel to another destination inside the home, or could be inside of your home, what happens is you have to put a disconnect in place. And when you do put that disconnect in place, that is where your bonding is going to land. Your bonding is going to land at your disconnect or at your main panel, whichever you choose to use according to the code rules. Again, there's a 5 feet rule. Any of your main service panels more than 5 feet away from the meter, you have to install a disconnect. So again, the difference between a main panel and a sub panel. Sub panel, you do not bond the sub panel once you've bonded at your entrance. You remove all bonding straps from the panel also. Your sub panels, all bonding straps must be removed. So neutral bounding at service panel, only one, there's only one bounding path, guys. Neutral bounding happens once, the service equipment. It happens at the service equipment. And again, main panel versus sub panel. Sub panels, you cannot bound your sub panels after the fact that you have picked up your main bounding point at your disconnect or your main service, which would be a disconnect or a panel. So also breaker sizing. For those who are tuned in into tonight's live stream and who missed the live stream, the start of the live stream, this is just a recap of what I spoke about in the live stream. So you can see there's a code rule that's on there also. Rule 14-104, rating of overcurrent devices. Overcurrent devices, breakers or fuses. So this rule refers to breakers or fuses, either or. Overcurrent devices, breakers or fuses, must not exceed the ampacity of the conductors they protect. Breakers are designed to protect the conductors for overheating. If the breaker rating is too high, the wire can overheat before the breaker trips. Example, number 14 gauge copper conductor on a 15 amp breaker. You have to follow that rule, not you're going to have a failure. Number 12 gauge copper conductor on a 20 amp breaker. Again, these rules are coming right out of the code book. So again, if someone installs, for instance, 14 wire on a 20 amp breaker, that becomes a code violation. And I'm going to, so right now, I'm just reading over what I spoke about at the beginning of the live stream, guys. Again, don't forget to like up the live stream as you guys enter. You can drop a comment in the comment section where you guys are tuning in from today. Are you guys a apprentice, licensed journeyman, licensed journeywoman, electrical contractor? Drop your comments in the comment section. So bounding continuity, that comes from rule 10-606, and bounding path must be continuous. Fault current must return to source. So your fault current has to return to the source. There has to be a path for your fault current to get back to. So your fault current has to return to the source, guys. Bounding ensures fault current return to the source, so your breakers trip. So again, bounding plays a big part in if your breaker is going to trip or not. So what this rule is basically saying is bounding ensures a fault current return to the source so breakers can trip. So this is why the inspectors are so heavily on this rule, because if it's not done correctly, and funny enough, I've met a lot of electricians who do not like bonding and grounding. The reason why I love bonding and grounding is because I did it for numerous times of numerous years. So I do know a lot about bonding and grounding. And bonding and grounding has to be done correctly in order for the equipment to work properly. and you see the rule states here that bonding ensures fault current return to the source so your breaker can trip. So what that basically means is if you do not bond continuously and you do not have a solid bonding point, your breaker is not going to perform the way it's supposed to, which is going to lead to overheating of the circuit. And we all know when the overheating starts, if your breaker cannot trip, then you have an issue. What that breaker does when it's going to trip, it's basically shutting down the entire circuit for protection. So bonding ensures fault current return to the source so your breakers can trip. So again, if you guys are tuning in to tonight's live stream and you're new here, I'm Fabian from Fabian Electrical Services Inc. And again, you can head over to my page, subscribe to the channel, and you will see me performing a bonding and grounding of a pool house. And you'll see how I picked up the actual bonding from the rebar. So the rebar is the strongest bonding point that you can have. So that is where I picked up my bonding point from to continue my continuous bonding path towards the pool. So basically, your bonding has to be continuous, cannot be broken or anything. It has to be a continuous bonding path. So rebar installed into the floor, it's basically a bonding path that you can pick up. Uh, Bless up yourself, TSC exclusive. I didn't realize that you checked in. Again, thank you for, or you just checked in. Thank you for tuning in to the live stream. And thank you for the support, continuous support. So bonding is very important. Again, you have to make sure that you have your bonding down pack. And again, that's the bonding continuity, and that's what it states. Rule 10-606 basically say bonding continuity, bonding path must be continuous, must have a fault current, also must return to source. So again, bonding ensures fault current return to the source so your breakers can trip. So without your breakers not being able to trip, you're in big problems. You're going to have big issues. And again, another topic that I discussed tonight was sub-rule mistakes, subpanel mistakes, common failures, neutral bounded in the subpanel. It also creates a parallel current path, causes inspection failure. So neutral is bounded at the surface, but isolated in subpanels. So again, that was your quick recap. For all those who are tuning in tonight, now we're going to go to the Q&A. For all those who wants to drop a comment, if you have a problem, if you're working on a job site right now and you cannot figure out a rule, or you're trying to figure out a path of running your cables, what to use, here's your chance. Drop your comment in the comment section and we can discuss. So again, for all those who are tuned in for the live stream tonight, don't forget to like up the live stream, drop a like on the live stream. You can also leave your comment in the comment section. The live stream, I was supposed to end it about 15 minutes ago, but I'm going to stay 5 more minutes to see who wants to interact with me. In the comment section. You can drop a comment where you tuned in from today. Are you guys tuned in from the Caribbean? Are you guys tuned in from Canada? Are you guys tuned in from USA? Are you guys tuned in from United Kingdom, China? Drop your comments in the comment section. Again, this is live Q&A. And for all those who missed the live stream tonight, you can catch it on the replay. So basically what I have here on the screen, guys, is basically the rules that I went over tonight. And if you do catch this on the replay, you're going to see mostly rules on the replay tonight. A lot of code rules on the replay. Okay. Olu Marty, I just got on. I like the title. We'll have to view later. Not an electrician, but just started learning networking. What kind of networking Ulu do? Sorry, I'm trying to read your name here. Excuse me, Ulud. So, what type of networking are you into? When you say network, are you talking about data cable? Normally, network involve some type of data cable. Network administration. Okay, so what are you doing when you said network administration? Are you networking from the USA? So again, welcome to the channel, and thank you for stopping in to the live stream. Again, this is a live Q&A for all those who are tuning in to the live stream. You can drop your comments in the comment section, and I will answer them live tonight. Tonight's live stream, you heard it. Ulu said, I just got on and I like the title. We'll have to view later. Not an electrician, but just started learning networking. So networking, like I said, I'm not sure if he's referring to the actual it's all electrical. It's all electrical. The only thing is it's broken down. Networking, to me, what networking is like data, Wi-Fi, security cameras, but I'm not 100% sure what he meant by that. But he just said he's from USA, and again, hope that you can follow the channel, and also if you have a comment, you can drop it in the comment section anytime. You're welcome. Learning so far basics and foundation. Okay, so what have you basically the touch basic and foundation? You said networking. When you say networking, are you referring to cameras? Are you referring to Wi-Fi, which we call data? Or are you referring to the strict electrical work? It is all electrical, but it's broken down. When you say networking, to me, you're talking about a data center or so on. So I'm trying to find out what you do, what you mean about what you're trying to say. Network. You say basic foundation. I'm guessing that you're just in the you just started and you probably don't know a lot of stuff. So again, for all those who are tuned in for the live stream, don't forget to like up the live stream. Live questions, you can drop your comments tonight. Um, Tell me where you guys are tuned in from. Are you guys licensed electrician? Are you guys a journeyman? Are you guys a journeyman, uh, journeywoman, DIY? Are you guys electrical contractors? Drop your comments in the comment section. Again, I'm replying to live questions tonight. Um, I did extended the live stream tonight, so for all those who are tuning in, drop a comment. I'll try to reply. Um, are you guys in the field? Are you guys working commercial, industrial? Do you guys work in homes, schools, high rises? Also, where you guys located? You can drop your comments. So again, what he's referring to is the topic: common electrical installations that fail. So there's a lot of common electrical installations that fail. Calvin Johnson. Um, Big up yourself, Calvin Johnson. I don't remember. CJ, I don't remember. Again, thank you for tuning in to the live stream. Again, also as you guys come in, don't forget to like up the live. Please and thank you. Helps with the channel. Again, it's a live Q&A right now for all those who are tuned in to the live stream. And again, you can drop your comment in the comment section. You can also join the channel, become a member of the channel, stay up to date to my content as I go live stream every once a week. Once a week, I do my live streams either on Wednesdays or Thursdays. So again, this is the live Q&A. You can drop your comments in the comment section. Also, don't forget to like up the live stream. Again, when it comes to common mistakes that fail inspection, there's a lot of them. But again, uh, neutral bounding in the sub panel is a common failure because a lot of guys don't know the difference. Again, it's one thing to understand the read the code book, but it's also another thing when it comes to practical. So practical makes a big difference. If you have a lot of practical in the field under your belt, when it comes to reading the code book, it's pretty simple. Um, so understanding what you do in the field and also dealing with learning to read the code book goes hand in hand. And again, when you do go to write your test, a lot of times you can remember from the knowledge of what you were doing in the field to answer those questions. It goes hand in hand. Practical, code book, practical. Um, that's what we basically go to school for. So again, I'd like to thank you guys all for tuning in to the live stream. Goon Platoon, TSC exclusive, um, Ulu Dumer, Troy, and Kelvin. So again, for all those who are tuning in, it's a live Q&A. You're more than welcome to drop your comments in the comment section for all those who are tuned in. If not, I will give the live stream another 5 minutes. So key points again in the live stream to remember also is overcurrent devices, breakers or fuses must not exceed the ampacity of the conductor they protect. Breakers are designed to protect the conductors from overheating. If the breaker rating is too high, the wire can overheat before the breaker trips. Example, number 14 gauge copper conductor, 15 amp breaker. Number 12 gauge copper conductor, 20 amp breaker. If someone installs a 14 gauge wire on a 20 amp breaker, that becomes a code violation. Okay, so you have to understand code violations do exist. Inspectors do look for those things. So when it comes to preparing for your termination and so on, it's always best to double check before you do call for a final. Make sure you double check from floor to floor, whether it be the basement, first floor, second floor. It's always wise to double check before you do call for inspections, because what's going to happen is you're going to call for inspection and you're going to wind up not having your electrical installation up to code, and you're basically going to get the defect. Now the defect, basically what's going to happen is once you get a defect, you correct the defect. You have a certain amount of time to correct your defect. Now this is based in Ontario, Canada. I'm not sure about other about other countries. Not really sure about the USA. I'm not really sure about England, Caribbean. I don't know how their rules go. I just know about Ontario, Canada. So again, for all those who are tuned in, if you are tuned in from the USA, drop a comment. If you're tuned in from United Kingdom, drop a comment. Let me know if your rules are a little bit different to ours. So again, tonight's live stream, tonight, welcome back. I'm Fabian from Fabian Electrical Services. So this is live Q&A for all those who are tuned in. If you want to drop your comment, you're more than welcome to drop a comment in the comment section, and I will answer your comment that you've posted. So yes, so again, it's always wise to double check, make sure before you go for your final that you do have everything up to code. Your inspection is going to run smooth. You don't want to have a defect on the final. Again, if you do have a defect, you have a certain amount of time to fix your defect. So a certain amount of time to fix your defect, guys. I'm going to take this off because I am talking from my phone here. So again, you want to make sure that when you go for your final, the defect, okay, you want to avoid all defects. You want to make sure that your breakers are lined up with 20 amp. Your 20 amp breaker is lined up with a number 12 wire. your 15 amp breaker is lined up with your number 14 gauge wire. You want to make sure that your 30 amp breaker is lined up with a 10 tree wire. Okay, you want to make sure that your number 8 wire is lined on a 40 amp breaker. Very important, guys. Again, for all those who are tuning in, tap on the live stream to like up the live. It helps with the channel. You can also join the live stream tonight. Live questions. Drop your comment. Are you electrician? Are you a journeyman? Are you a journeywoman? Um, are you a DIY? Are you a local contractor? Um, Drop your comment in the comment section. Where are you guys located from? Are you guys located from Canada? Are you guys located from United Kingdom? Are you guys located from the Caribbean? Are your code rules a little bit different from this rule that's here on the screen? Or are your rules the same as where you're located to here? Again, rules can differ from countries to country. So the rules that I'm going over right now is based
So again, sorry about that, guys. I was using my other phone as a backup. Normally, that's what I do, so I don't cut off of the live stream. So again, yes, drop a comment where you guys are located from. Are you guys located? Like I said, I hope you guys can hear me. Let me see here. Yes. So again, drop a comment where you guys are located from. So again, this is a live Q&A. This is a live Q&A tonight going on. So for all those who are tuned in to the live stream tonight, where you guys located from? So again, I'm going to give the live stream another 5 minutes here of a little bit of explanation of when it comes to bounding and when it comes to bounding and grounding, guys, it is very important when it comes to the bounding. Always make sure that you do have your bonding intact for final for your final. You do not want to have the inspector come and you basically have everything not working, guys. Everything, nothing up to code. You want to avoid that. So again, for all those who are tuning in, welcome back to the channel. You're tuned in to Fabian Electrical Services Inc. And again, um, this is a live Q&A, live Q&A for all those who are tuned in. So like I said, for all those who are tuned in, I'm going to give the live stream another 5 minutes here before I log out. So if you do want to drop your comments, you can drop it before I log off of the live stream. So again, for all those who are tuned in to the live stream, I'm Fabian from Fabian Electrical Services Inc. If you do catch this live stream on the replay, don't forget to give it a like up the live stream. It does help with the channel, you guys. Again, for all those who are tuned in right now to the live stream, don't forget to like up the live stream. Tap on the live stream to like up the live stream. It does help with the channel. Again, I do go live every either Wednesdays or Thursdays is my normal schedule. However, I cannot go live tomorrow, so that's why I'm doing my live stream tonight, guys. So for all those who what the hell? So for all those who are tuned in to the live stream tonight, simply tap on the live stream. Helps with the channel. Again, this is a live Q&A tonight. You can drop your comment in the comment section. I am going to give it. So again, guys, your common mistakes that you guys see on the job site. Um, what is the common mistakes you guys as electricians or journeymen or journeywomen or apprentices you guys see on your job site? You can drop it in the comment section. Do you guys see, round breaker sizing? A lot of times it does happen. Round breaker sizing happens. We're in a rush. Sometimes we don't pick the right breaker. Whether it be an art fault or so on. A lot of times, like I said,
We
we
don't
don't
pick the right breaker size.
we don't
Sometimes we just pick
pick
the
the
breaker
breaker
from
from
the
the
tool box,
tool
and
box and
we go and install it. Again, it's
install it.
very dangerous when
Again,
it comes to that. Um, again,
it's very
if you have the wrong size
comes to that.
wire,
Um, Again,
for instance,
if you have
number 14 wire on a 20 amp breaker,
size wide,
that's wrong. That's basically asking for overheating.
for instance,
Again, guys,
14
don't
that's wrong.
forget to tap on the screen, like up the live stream,
That's basically
helps with
asking
the
for up on the
channel.
screen, like up the live stream, helps
Again,
with
you can
the
also
channel.
drop your comment in the comment section.
Again, you can also drop your comment in the comment section.
So again, yes,
So again,
guys. So,
yes, guys. So,
oh, you guys are still here. Okay.
oh, you guys are
Okay. I
still
guess I have
here.
to go.
Okay.
So again,
Okay. I guess I have to go.
just drop
So
your
again,
comment in the comment
just
section, guys,
drop
and
your comment in the comment
I will
section,
answer them
guys, and
tonight.
I will answer them tonight. Where you guys tuned in from tonight? Again, also don't forget to like up the live stream, guys. Tap on the screen, like up the live stream. It basically helps with the channel. Um, all I simply ask is to tap on the screen to like up the live stream. Again, this is live Q&A. You can drop your comments in the comment section. Again, service, or do you guys normally stay with 100 amp, 200 amps? Are you guys commercial slash residential license electricians? Again, me myself, I'm a commercial license guy. 15 years in the commercial industry. So again, commercial commercial / tend to know a lot more than residential, because we deal with a lot of high voltage stuff, transformers, a lot of disconnects and so on, three phases, sharing neutrals and so than residential. So again, are you guys commercial licensed electricians? Are you guys house wiremen, we call it? Again, where you guys tuned in from, you can drop your comment in the comment section. So again, you have this rule on the screen. You guys can go over that rule. Again, that's part of the through tonight. That is part of the live stream that I've went through tonight, guys. Again, for all those who are tuned in, you can tap on the screen to like it up. You can also drop your comment in the comment section, guys. Again, this is a live Q&A for the live stream tonight. Simply drop your comment in the comment section. Tell me where you guys are located. Are you guys licensed electricians? Are you guys from the commercial sector? Do you guys do mostly service, or do you guys do a lot of what do you guys do? Fire alarm systems? Are you guys experienced in bonding and grounding? Again, this is part of what we discuss tonight on the live stream. Bonding and grounding is very very big when it comes to the inspectors. It's high on their list. Reason being is it protects and saves lives, and um, when done correctly, it's supposed to be done correctly. So when it is done correctly, it's another day on the job site, knowing that you perform your due diligence when it came to your electrical. Again, guys, don't forget to like up the live stream and tap on the screen to like up the live stream. Helps with the channel and bonding continuity. Again, you have to maintain your bonding continuity throughout your run. That is part of what I discussed through the tonight's live stream. Again, that is the rule. You're going to see the rule pulled up on the live stream tonight, right beside me here. How I have it. This is how the live stream is structured tonight. You will see me talking, and you will see the code rule right beside for you guys to just follow along the code rule. Again, how I go about finding my code rules is simple. You can either go to the front of the code book, or you can go to the appendix in order to find what you need to find. For me, I know it off the back of my hand, so I basically just flip and I keep going until I find that rule. Again, this helps also when you do go to write your masters. When you do go to write your masters, you are going to sit down in there for over about 4 hours to do a test. So you have to know how to travel back and forth between this book. You also have to know to travel back and forth when you go to write your CFQ inside of the same book. So what I've learned is tagging the code book is very important when you're tagging the code book. It helps you to find your rules a lot faster. It helps you to maneuver a lot faster when you have tabs in your code book. It also helps you a lot when you do remember where to go for the rules instead of going to the front of the page or the back of the page. Again, this is my experience of years of working in the field, and obviously going about it every day is what I've learned how to maneuver throughout the code book. Now, you would have seen me reading out these code rules tonight. So again, when it comes to the code rules, there's a lot of hidden words inside of the code rule itself. There's a lot of hidden words and so on that you have to read more than once. So a code rule is never meant to read once. A code rule is meant to read twice. Once you read the code rule twice, you're good to go. If you read the code rule once, you're not going to get that rule. You have to go back and read the code rule a second time. What happens when you read it the first time? You do not catch the rule the first time. When you read the rule the second time, which you saw me doing tonight, when you read your code rule the second time, it's basically reassuring that that rule that you're reading, you're understanding the rule that you just read, and you're not just going to do the job 100%. It's important. The code book is very tricky. Again, it's a very tricky code book. It's not difficult to read. You saw me maneuvering through the code book tonight when it came to my service bounding rules, which is under 10-204. Basically, what I did was I simply went to that rule through the sharing the screen. But again, if I am using a regular code book, I am going to show you guys how I do have my code book. Um, so this is my old code book here. Again, what I did was I don't know if you guys can see this, but this is my old. Can you guys see that there? So this is my old code book here, and this is how I tag. You see that there? This is how I tag my code book. So when I tag my code book like this, I have every single page tag. And when you tag your code book, basically you know where to go when you tag your code book. So I didn't learn this until I became a licensed journeyman, maybe when I was going to write my master's. I learned to tag my code book. When I tag my code book, what basically happens is when you go to write your test, you can sit down and write your test, and you can maneuver through your code book with all of these tags in here. It helps. So that's what I used to use, but now I use my iPad, and everything is on my iPad, and everything is a lot difficult to maneuver. So this is why I keep one iPad as my code book when I'm maneuvering and going around to job sites. And when I'm at home and I want to maneuver in the code book, I basically refer to this book. Again, this is an older code book, but a lot of the rules also stay the same. It's an older code book, but a lot of rules either get deleted from the code book, or a lot of rules either get relocated to another spot. So again, also a lot of stuff that I do um, is planned. You guys, again, highlighting your code book is you know, very important. As you can see, I have my code rules highlighted. So it's all part of learning as a license guy. Again, when you first start the trade, you're not going to know that. You learn it as you go. Again, guys, tap on the screen. Tap the. Don't forget to like up the live stream, guys. Again, um, there's a lot of people action in the on the live stream tonight right now. So, okay. So again, when you go to write the test, guys, it's very easy, simple. Um, this is how I was able to maneuver tonight in the code book. It's very easy for me to maneuver. It's also very easy for me to come here on the live stream and break down the code book. So when you see me breaking down the code book, I'm breaking down the code book and the code rules because I understand the code rules. I'm breaking down the code rules because I work in the field and I can relate to the code rules. It's very important. Also, a lot of times you don't learn the code book with your licensed journeyman that you're going to start with. They're just going to point you to do that, and it's up to you to basically learn the code. So with me learning to read the code book, I can maneuver through these rules, grounding rules 10-102, service bounding rules 10-204, subpanel mistakes. Subpanel mistakes is basically um, something that there is a rule in there, but subpanel mistakes, it comes from experience. You do the job a couple times, you're going to remember your subpanel mistake that you made. So subpanel mistakes. That's why tonight's live stream is named the way it's named, common electrical installation that fails. So basically, common electrical inspection that fails. These are all common electrical inspection that fails. But understanding the code book is vital to your path to success. So again, this is a live Q&A, live questions. I'm just trying to fill in. Um, I figured there would be someone else dropping a comment, but got carried away with the book here, guys. And again, I would like to thank you guys all who tuned in to the live stream tonight. Again, you can also, for all those who are tuned in to the live stream, you can don't forget to tap on the like up the like button, helps with the channel. Also, you can follow me every either Wednesdays or Thursday on the live stream here. I do my live streams every week, guys, for whoever are tuned in to the live stream tonight. Also, I do go live around this time, around anywhere from between 6 to 9 is my time frame for going live. So a lot of times you guys might not get my notification. Um, if you do subscribe to the channel, just make sure you hit the bell notification. Make sure that you are tuned into, subscribe, you hit all. Make sure your notification is turned to all. That way you receive my notification. So again, tonight's live stream, common electrical inspection that fails is common in the industry. Also understanding the bonding rules. So this is basically the back of the book, guys, and this is table 34. You've got table 34 here. Again, These are all rules that we have to follow. And also, if you can see how thick that this code book is, so imagine you guys having to try to memorize all these rules. Again, the key is to find the rule. And basically, finding the rule is basically knowing how to get to the rule. So, again, the key of the code book is not to memorize it. There's no way someone can memorize this book. Okay, there's no way you can memorize this book. Okay, basically what happens is you know how to get to these rules. Okay, yes, there are some code rules that you're going to know off the back of your hand and so on. There are some stuff that I know from the back of my head for this code book. A lot of stuff I haven't touched. I just know how to find it because I know how to read the code book. Very important, guys. So again, um, for those who are tuned in to the live stream, I am way over. It's an hour and 40 minutes into the live stream. Again, for those who are checking in to the live stream tonight on the channel. So again, this is a live Q&A. For all those who are tuned in, you can drop your comment in the comment section. Tell me where you guys are tuned in from. So again, I wasn't expecting to have traffic back and forth in the live stream tonight, but however, it did happen. So we are here right now. So you can drop your comment. Where are you guys tuned in from? Are you guys a licensed journeyman wireman, licensed electrician, journeyman lady, journeyman wireman? Are you guys electrical contractor? Where you guys are located from? So again, breaker sizing failure, very important. Breaker sizing failure. You don't want to fail your inspection, guys, because of the breaker sizing failure. You want to make sure that when it comes to the breaker sizing, that you follow the rules that are laid out. Again, the rules that are laid out for the breaker sizing is 14 104. And 14 104 is rating of overcurrent. And again, key important factors for that code rule is overcurrent devices, breakers or fuses must not exceed the ampacity of the conductor they protect. Breakers are designed to protect the conductors for overheating. If the breaker rating is too high, the wire can overheat before the breaker trips. Example: 14 gauge copper conductor, 15 amp breaker, 12 gauge copper conductor, 20 amp breaker. So again, if someone installs um, 14 gauge wire on 20 amp breaker, that becomes a code violation, guys. So you don't want to do that. You want to avoid that, guys. So again, tonight's live stream full of code rules. Um, you can basically, when you do catch this on the replay, you're going to find that I have the rule here, numerous rules that I did go through tonight. And again, the rules was basically 14 104. It's going to have the timestamps inside of description, guys. Again, it's going to have the timestamps inside the description. Again, guys, I will be dropping a short on Friday. I ask you guys to support and make sure you guys like up the short on Friday. Like up the shorts. And again, um, the key rules that I went over tonight: 14-104, rating of overcurrent devices. Okay. Rule dash 104, maximum. That all those who are tuned in into the live stream who missed it on the opening. Here's the rule. Rule 8-104. Maximum circuit loading. Continuous loads must be calculated at 125%, okay, of the load, which results in the 80% breaker rule. Very important, guys. This rule is very important, and you're going to see why this rule is very important. A 20 amp breaker can only carry about 16 amps continuously. That means that if you have a 20 amp breaker, if you guys have a 20 amp breaker, okay, and you have a number 12 wire, number 12 gauge wire, then your number 12 wire can pretty much go on the 20 amp breaker. However, if your circuit exceeds the 80% rule, then you have to upsize that wire again. Let's say, for instance, you have a 20 amp breaker on a number 12 wire and you're drawing 16 amps. Again, it's kind of um, it's kind of taking the risk. Um, but again, you have to size it accordingly, and that's where this rule comes from, guys. A 20 amp breaker can only carry about 16 amps continuously. Breakers protect the conductors, not the equipment. Okay, if the breaker is oversized, the wire can overheat before the breaker trips, which is a serious safety issue, guys. So again, this is where I am going to log off the live stream. As you guys keep entering, again, you guys, I would like to thank you guys all. Don't forget, for all those who are tuning in, if you do catch this on the live replay, don't forget to like up the live stream. Again, live Q&A. If you guys want to drop your comments, you can drop it in the comment section. Um, so again, 20 amp breaker. I gave you the example of a 20 amp breaker, gauge wire. So a 14 gauge wire can only go on a 15 amp breaker. Rule Reason being is your 14 gauge wire can only carry a certain amount of current, and having a 20 amp breaker on a 14 gauge wire, you're now asking for problems. You're now asking for overheating. You're asking for a whole lot of problems. And again, you want to avoid that. So that's why you size accordingly. And then again, you have inside of this live stream tonight, you had me explain the bonding continuity. Bonding continuity, very important. You have to make sure that the bonding continuity is done correctly. Again, if you watch my videos, you'll see me doing videos on the pool, and that's where I did my bonding and so on. So when it comes to pool, when it comes to the pool, is very important. It's very important for the bonding. You can catch my videos. You'll see the bonding important. Reason why you have to bond the pool to code, okay, is because you are going to become the first path back to ground. So, for instance, if there's a lightning and you're in the pool, you decide to get out the pool, the lightning decides to strike on the ground. Now you're coming in contact with the ground. Again, there's also a rule that states that if it is from the pool rule section, I believe it's 6800, something like that. If you do step out the pool and the pool is not bonded properly, that's why bonding is very important. If you are within that certain um, meter or feet of the pool, you have to have that path bounded off. Um, Same thing with your pool on the top. All metal enclosures has to be bonded together. Same thing with the pool. If you have a pole light for some reason, you have a pole light. If you have receptacles that are metal for some reason, normally they're conduit. If you have a light that is metal, if you have an in-ground lighting that has metal, it has to be bounded off. It has to be bounded off, guys. So it's important to bound off the pool accordingly. It's also important to bound off what is inside that perimeter of the bounding. Very important. Again, um, bonding, when it comes to bonding, also how I took my bonding from that job. Bonding, I did bonding continuity. Again, you can all find this on the channel. You can find it under the masterclass bonding series that I do have. Oh, and again, also you also can so the bonding pool, you probably masterclass series, the bonding and grounding title that I have on the channel. Very important. Um, Bonding that there's a hot tub, and what I did was from the hot tub, because the hot tub went down a certain amount of feet into the earth. I basically took my bonding from the ground. So again, guys, it's important to understand where you're going to take, where you can take your bonding from. You can take your bonding from any structure, anything that says that's rebar, that is according to the plan or the rules that's laid out in this code book here. You can take your bonding from there. So that's what I did. I took my bonding from the hot tub. I brought it up and I distribute my bonding on the pool. Okay, and also what I did with that same bonding is I picked up the steps, the pathway that needs to be bonded to protect you from injuries when you decide to get out of your pool in the midst of a rain and lightning is going. So, sorry guys. So very important, bonding. The bonding rule is important to us, and it's also important to protecting the lives of other ones from anything happening. So bonding, very important, guys. Never take it for granted. Always make sure that you double check with the code book when it comes to the rules uh, and so on. So again, you guys, this was supposed to be a live Q&A. However, people are coming and going, and again, this is almost an hour, almost 2 hours live stream. Um, okay, guys. So again, I would like to thank you guys all for tuning in to the live stream tonight. Also, again, thank you guys all for supporting the channel. Again, also for all you guys who tuned in to the live stream tonight. I would like to thank you guys. You had Gloom Goon Platoon, TSC Exclusive, Uludu Merrick Troy, and again, also you had Calvin Johnson, Reggae Don. Again, thank you guys all for tuning in to the live stream tonight. But again, um, so all right, everyone. Before we wrap it up, let's recap the key points from tonight. So again, grounding stabilizes the electrical system. Bounding provides the fault current path that allows your breakers to trip during a fault. So again, never forget that. Okay, I'm going to read that over again before we head out. Um, Again, grounding stabilizes the electrical system. Bounding provides the fault current path that allows breakers to trip during a fault. Again, remember, neutral bonding happens at the service equipment only, and subpanels require neutral isolation to prevent parallel current path. These are some of the most common electrical mistakes that causes installation to fail inspection. If you're interested in electrical code explanations and real electrician training, make sure you subscribe to Fabian Electrical Services Inc. I'll be continuing the Electrical Masterclass series in the next episode. And before we go, let me know in the comments what electrical topic you'd like to see in the next masterclass series. Again, thanks for joining the live stream tonight. Stay safe and keep your installation code compliant.